Assalamualaikum and a very good evening. So I need to do the question for number 1. So for the 1C, we need to use the Maple or Mathematica or MATLAB to plot the graph. And for the question 1C1, we need to evaluate the n. Okay, we need to evaluate the n. So the n here was given from the question. Okay, and then after we type this, we need to enter, and we need to insert a function. Function here we can get from the question. It's here. Function equal to x and L equal to k equal to 1. So this is function equal to x, L equal to 1 here, and then the value we type here, value bn, and the mapper can calculate this for us on the spot. Okay, we can, and then we simplify it like this, and we got this, -2 bracket 21 power of n over pi over n, pi n, and okay, this is the n we get. And for question 1C2, we need to determine the first 5 coefficients in the series. Okay, we need to we need to put the sequence. I use the command sequence is sequence bn. Bn here, it's just like I recall the bn up there. Okay, and the n is 1.5, and then we got this. Okay, we just put the what question given, and we can get this. Okay, for the question number 3, 1C3, we need to sum the 5 terms in the series. Graph the sum for t is equal to 0 to t equal to 1 in step of 0.2. Okay, we put the k equal to 1 and u bracket and xt, and insert the equation. U here is n here is just number we want to put anything number. Okay, since the question asks for the first 5 terms, so we need to change the n here for 5xt, and then we enter, we can get this. This is the first 5 term series. For the graph, we can use the equation here, just put the graph, and we just change the t to 0.2, 0.4, 0.6, 0.8, and 1.0. We also, since the x is 0 to 1, so we put it here, 0.1. Dot is equal to 2. Okay. This is for the title. For the graph, we can put the title, graph the sum 5 term series for t equal to 0, t equal to 1 instead of 0.2. Okay, and then we got the graph here. Okay, if you want to plot the 3D graph, you can just add 3D here, and we can get the graph 3D. Okay, I forgot to do that, but if you want to do, you can do the 3D graph. Okay, I just do the 2D graph. Okay, for the question number 4 here, we need to verify k, investigate the behavior of mental bug integer through reports of u, xt for x from 0 to L. Discuss the findings. Okay, here I just put the k equal to 0.5 and plot the graph, and I got this. Then I put 4 different value of k. Okay, 4 different value of k. First, I put the k equal to k equal to 1. Then k equal to 0.5, k equal to 1.5, and k equal to 5. As you can see, if I put the k equal to 1, the graph of the line here is bent, just a little bit bent. And then if I put k equal to 0.5, it becomes more bigger. The space become more bigger. If the k is smaller, the space of the graph is bigger. And if k equal to 1.5, it becomes smaller. It looks more narrow, like this. Okay, we cannot see the other 3 lines. And I just put k equal to 5 just to differentiate it more clear, and I got the graph like this. As you can see, it's clearly that there's no more line at the bottom. Okay, it's already flat. Here. Just only this line. Okay, so I can sum up here that if the k is bigger, the graph is become more decrease. The graph line is decreased. And I can conclude here that K is diffusivity of the metal bar. So when the K is bigger, the line is narrow and decrease. So we put the K just to investigate the behavior of the metal bar temperature from the graph. We can see that K is increased. The temperature function has smaller maximum. It means the line here is maximum become maximum if K is increased, and this means that the higher value of K, it make the heat more diffuse more quickly, rapidly to 0. Okay. Then we up for the question number 5, we need to repeat the C1 until C4 and compare the result to those found in C3. Where? Okay, for the question number 5, is given the principal function x and interval 0 to 0.5 and 1 minus x to 0.5 to 1. Okay, we need to find their new Bn. Okay, I just calculated and I'm not calculated, but I insert the equation given, and this is my new Bn, but I put it here is An to avoid the confusion. So I put this equation that was given like this, and I press the enter and it will appear like this. Okay, and to calculate it, it will appear like this, An. So if I want I want to calculate the first 5 term series. So I just put it here, and I got this first 5 term here. And same goes with the previous equation number 1, C1, C2, C3, C4. Okay, I just plot the graph like the equation that I got, like this, and just change the T0, 0.2. But I put the new, if the previous one is U, but I put it is S. Okay, you can differentiate that, and you can compare that with the previous one. Okay, this is the new equation of An, and the T is, I changed the T like that, like this, and we can see the graph is totally different like this. Okay, the graph is like this. So I just changed the K to make it like the previous equation. I changed the K from K to equal to 1, K equal to 0.5. Okay, as you can see, it's become smaller, it's decreased, it's increased. And K equal to 2 is decreased, right? The line below almost and below almost flat. Okay, it means the higher the temperature, it's quicker it goes. Alright. Okay. For the question, to compare the result found in C3, I pass it to my groupmate, Naziha binti Muhammad. So she can explain more about it later after this. Okay. Thank you for watching my video, and okay, that's it. Thank you. For question 2B1, we can use any type of software, so in this case we use Maple. First, we need to define a few terms. Function of f equals to x, l equals to 1. Then we define our eigenvalue, cos, sine equals to 0, lastly k equals to 1. To find Bn, we have to substitute the information given into the formula. Then we will obtain the answer. For question 2, we have to determine the first 5 coefficients in the series. So, we let n equals to 1 to 5. Then, we can find the sequence by using Maple. Question number 3, we have to find the sum of the first 5 terms in the series and then graph the sum. First, we have to put the equation, and then we substitute n equals to 5, and you will get the answer in terms of n, x, and t. Then we plot. We plot using plot 3D. We put the general solution inside, and then we will get the graph. For question 2C, we have to discuss the difference between graph 1 and graph 2, which we obtained from 1C3 and 2B3. Based on these two graphs, the feasibility for the metal bar is k equals to 1. As you can see, in graph 1, the graph dropped rapidly, while in graph 2, it dropped constantly. So we can conclude that graph 1 dropped rapidly to 0, while in graph 2, it dropped constantly.